Welcome back, guys. So in this video here, we're gonna go over how to factor difference in square and factor in perfect square trinomials. These are special polynomials. Um, the ones that we really want to be able to factor is difference in square. The perfect square trinomials, we can still factor these trinomials without knowing the special formula. But let's go ahead and just mention it a little bit here. So if we have x squared plus 6x plus 9, and if we were to factor this here, then this polynomial will factor into x plus 3 and x plus 3, and that essentially just x plus 3 squared. So this polynomial will factor into a factor square, so that's a perfect square trinomial. So this right here is a perfect square, right? So therefore this here is a perfect square trinomial. And there is a formula for that, okay? So if we have a squared plus 2ab plus b squared, then we can say that trinomial can be factored into a plus b, the quantity squared. And if we have the trinomial where it's minus in the middle, where the middle term is minus 2ab, then the factor would be the a minus b squared. So you can see on the first one here, our x squared minus 10x plus 25, we can say that in this case x squared minus 2 times ab, in this case a is going to be x, b is 5, so we can say 2 times 5x plus 5 squared. So or a in this case is x and or b in this case is 5. So this trinomial fit the perfect square trinomial formula, which is this here. Okay, so that's twice of ab, since a and x and b is 5, so that's twice of that right in the middle. So this is just going to be factored into a minus b, which is 5, and then square. Okay, and we can check that, that will come out, correctly. All right, so that's x squared minus 10x plus 25. All right. Next one, we have 16y squared plus 49 plus 56y. So what we can do here is we can rearrange the 56y term in the middle, and then we can see that, okay, well, this happened to be a perfect square trinomial as well. So a can be written as 4y squared, and this is 2 times 4y times 3. No, 7, because 49 is 7 squared. So 4y times 7, and then this is 7 squared, and that would become just 4y plus 7 squared. As you do more of this, you get better. But again, like I said, with the perfect square trinomial, we don't really need to know the formula. We can just factor using just the guess and check or the trial error method. But anyway, in part C here, 25x squared minus 20xy plus 4y. So this is going to be 5x for the a. B is going to be 2y. And then we're going to have a negative in the middle because the middle term is negative. So that factor into that. Okay. Difference is squared, right? When we have x squared minus 9, okay, it turns out if we have a square of a difference of 2 square, then we can use this difference of square formula. This is going to factor into x plus 3 and x minus 3. Okay, and this is where this comes in. So this is going to be a squared minus b squared. Okay. So let's apply that. Okay, so p squared minus 81. So we can say that this becomes p squared minus 9 squared. So our a is p, and then our b is 9. So the formula say that is going to be a minus b times a plus b. So we have p minus 9 and then p plus 9 as two factors of difference square. And then here, or a in this case is going to be 2x, and then our b is going to be phi. So we have 2x minus phi, and then 2x plus phi. Okay. C, we can say that our a is phi a squared, because that's how we get 25a to the 4. And then b will be 3b, because 3b squared is 9b squared. All right. So we have phi a there, 3b there, 3b there, plus minus or minus plus. Either way is fine. Okay. Part D, we can look at this and say, okay, x to the 4 is x squared, and then 1 is 1 squared. So a is x squared, and then b is 1. So the difference of formula becomes a, in this case, x squared, b is 1, and then x squared plus 1, so a plus b, right? But this is also a difference squared. It can be broken down further. Okay, so we can say x squared minus 1, that becomes x minus 1 and x plus 1. And then the x squared plus 1 doesn't factor because the difference is squared. This difference is square here. This formula only applies for difference of square, not sum of square. So the x squared plus 1 doesn't factor. Let's try a couple more examples. All right, so 7 minus 7, p to the 4 and q is 6. In this case here, we don't have two squared, a difference of 2 squared, because a 7 is not something squared, or 7p to the 4 q to the 6 is not something squared. So we want to apply the GCF first by taking out a 7. Okay. And that becomes that. Then we can apply the difference squared, because 1 minus p to the 4th q to the 6th is a difference of 2 squares. So we do 7 times 1 minus p squared q to the 3rd, and then 1 plus p squared q to the 3rd. Okay. So some polynomial, you have to take out the GCF first. In this problem here, I think the GCF is y that you want to take out first. So y come out 16x to the 4 minus 81. And then from there, we can see that this is 4x squared minus 9. And then 4x squared plus 9. But this is a different square. So that becomes y times 2x minus 3 and then 2x plus 3, which are the two factors of 4x squared minus 9 there. And when we do difference of square factoring, we want to be able to factor as much as possible, meaning the term is completely factored. So that way, you don't leave any factor that is a different square and just box the answer. We want to factor as much as possible. I'm going to do this one here. This is a difference of square too, but it's kind of weird. Our a in this case is 4. Okay, and our b is x minus y. Right, it's just our b is now is binomial. So we can apply the difference of square, right? A minus b, a plus b, right? So let's see here. So we can have 4. Let's do a minus first. So b in this case is x minus y. And then after that, a plus b in this case is x minus y. Okay, and then we can simplify. 4 minus x plus y, and then times 4 plus x minus y. So sometimes you see this here, this weird difference of squares. Okay. So I think that's plenty example. In the next video, I'm going to go over how to factor sum and difference of cubes.